contractors and the shoulders of particular sudden contraction of pipe, there is some kind of losses that has been occurred, right? So these losses we can calculate H. Head loss is equal to K friction factor upon V square upon 2G, right? So that friction factors is different for the different kind of losses we have to consider. Now the next type, that is losses in the elbows and pipe beds, right? So these losses are again depends upon L equivalent of by K. So L equivalent is nothing but the equivalent length of duct, and KD is nothing but the dynamic loss coefficient that has to be considered. So these factors are not only depends on the velocity, but this or depends on the surface roughness and the particular geometries of the pipe bend and the, we can say, elbows, right? So we have to consider this factor while designing particular, so that there should be a minimum losses have been occurred. Again, if you consider the elbow, so there is an aspect ratio, right? Aspect ratio, and the second parameter, that is nothing but the radius ratio. So this parameter we have also considered. We have to also consider while designing or selecting a particular type of elbow, bend and elbow for a duct arrangement or supply arrangement. If you consider the aspect ratio, it is nothing but the ratio of longer side upon the smaller side, right? So that is the ratio of duct cross section. So if you consider this is the duct cross section, so it has A is a longer side and B is a smaller side. So ratio of these two is nothing but the aspect ratio, and aspect ratio is very important parameter while selecting a particular kind of elbow or pipe bend, because this directly affects on the particular cross section area. So if the aspect ratio is going to increase, this leads to increase a particular cross section area of ducts, and that will increase the material cost. And this is, as it is not only increases the material cost, it's also contribute to the heat gain because of increase in the surface area, so that is not desirable. So therefore we have to consider or we have to select a particular elbow or bend that should have a minimum aspect ratio, right? Ratio should not be greater than 3, and the radius ratio should be less than 3, and the radius ratio should be 1.5, right? So aspect ratio greater than 3, this causes to the increase in the losses of pressure, so that is not a desirable case. So it should be less than 3. Now the second parameter, that is nothing but the radius ratio. It is the ratio of radius, that is center line radius of elbow, upon the width of a particular curvature surface. So that's radius ratio. In standard case we have to select it is 1.5. So in order to avoid the losses in the elbow, loss that we have to consider is suction and discharge loss, right? So whenever the air handling unit is connected and we are supplying the air with the help of branches or with the help of some supply ducts connecting one passage to another passage, so there is a suction will occur, and from one passage to the second passage there is a discharge will happen, right? So at suction side, if you consider this is a duct, okay, and air is entering here. So inside the pipe, when the air is enters at certain distance from the entrance, let's say length of entrance L, there is a vein of contractor will form, right? And because of that, there's some release losses will may occur. So that is nothing but the suction loss. Similarly, that kind of loss will occur in the discharge side. So for that purpose, we have to consider this formation of, so there is a uniform flow of air will occur. The drip loss, pressure losses in the pipe fittings and the leakages. If there is some kinds of leakage in the duct arrangement, this leads to the minor losses. Joining of pipe or fittings, if you are providing, then there's kind of losses. Also, we have to consider if no losses, then velocity head will get converted into the pressure head. But that pressure head we have to consider, that is while designing the pipe. So that pressure regain factor, loss regain factor, we have to consider, that is circular pipe, so 0.9, and rectangular pipe, that is RG is 0.5. So that loss you have to consider, even though the velocity loss is converted into the pressure loss. Thank you. Learn about different kind of losses in case of duct system. For efficient air conditioning systems, we have to supply the air at a better velocity, so that there should be a minimum pressure losses that has to be occur. Again, there should be a uniform distribution of air throughout the conditioned space, right? So these factors we have to consider while designing a duct system. We learn about the losses in fluid mechanics, that is major and minor losses. So these are the basic two categories while classifying the losses occurs in the piping system. So same losses we have to consider while designing the duct system. We know that the major loss, that is nothing but the part of friction pressure loss. So how it is? So whenever the air that is supplied from the main air handling unit through the supply ducts or return ducts, so if the air is supplied through the ducts, the air particle, there is a friction between the air particles, and the friction between the air particles and the surface of inner surface or internal surface of the ducts. So that is causes to loss of pressure inside the duct system. So that loss we have to calculate while designing the duct system. So that loss we can calculate with the help of this formula, that is HF, head loss or pressure loss in terms of head is equal to F L V square upon 2GD. So here F is nothing but the friction factor, so which is depends upon the Reynolds number 64 by RE. So if you consider the Reynolds number is less than 2300, that is laminar flow, and greater than 2300, that is turbulent flow, right? So as per that we have to consider the friction factor. L is nothing but the, if you consider this is the duct, so L is nothing but the length of that particular duct, V is the velocity of flow of air, and D is nothing but the equivalent diameter of particular duct. So with the help of this we can calculate the surface friction loss. Now the second loss that we have to consider, that is minor losses, dynamic losses that has been occurred. So the dynamic losses occurs because of the change in velocity, or we can say change in the magnitude of particular flow, right? So if there is a change in cross section, of course there is change in velocity will occurs, and if there are some change in the cross sections, just like elbow or bends in the pipe, these are responsible for changing the magnitude or changing the direction of the particular flow. So this contribute to the minor losses, right? So let's see one by one what is that. If you consider the first loss in the minor loss, that is loss due to the sudden enlargement, right? So if you see, this is the enlargement. If you have taken the air in this supply from the entrance, and if there is a sudden enlargement in the pipe or supply duct, because of that this sudden enlargement eddies are formed near to the shoulders, right? So this eddies form will causes to loss of pressure drops, right? So that should be avoided. So in order to avoid a particular this loss, we have to should not have to provide these types of corner. Instead of we have to provide like this type of arrangement so that uniform flow will occur through these passages and there should not be any loss of pressure, right? Whenever there is a sudden enlargement, right, so initially there is increase in cross section area, means as the area of cross section increases there is a velocity head will going to convert into the pressure head, right? So velocity will be converted into the pressure, means there is increase in the pressure, right? So this is related to the sudden enlargement. Now the second factor that cause for the minor law, that is the sudden contraction.